Hi again, sports fans. What do you say we look at something called consecutive integer problems? Hey, and welcome to the channel. If we're just meeting, my name is Mark Nolde. I've been teaching high school math for almost 25 years now. In fact, I'm in my 24th year at my current school. So today we're looking at another one of my favorites, consecutive integer problems. These are great beginner word problems. They really test our reading skills. So they're very important problems, I think, for starting out with word problems. So let's begin. So if we use like the letter N, say, we use N for number a lot, but say we use it just to designate some unspecified integer on this number line. And then we look at it and we say, all right, we have like a 0 and a 1 and a 2 and a 3. And integers also go negative, so we could be coming down here as well. But if I just let the number n equal any given integer, let's say I'll call this one n, the next consecutive integer, this 2, is going to be n plus 1. So we have to read these problems kind of carefully. So this integer we would call n plus 2, and so on. So this is the idea with the consecutive integer problems. So let's go on and look in the quick example. This is a typical example for beginners. It says find 3 consecutive integers such that the sum of the first and third is 142. So one thing I like to have my students do is just make a number line. So I don't know what the numbers are, but I just know that there are 3 numbers in a row. So I'm going to say, let's let the first one be n. That would make the second one n plus 1, and the third n plus 2. So this is the first, this is the second, and this is the third. So we have to read carefully here. It tells me the sum of the first, that's this one, and the third, that's this one, is equal to 142. So I'm going to set that equation up. So the first plus the third. So let's say I have the first, which I know is n, that's this one right here, plus the third, that's this one right here, n plus 2, we don't know what n is yet, and the sum of those two is equal to 142. So I'm going to solve this like just a regular linear equation. Combine my like terms, and then we write the next equivalent equation. And then let's go ahead and subtract 2 on each side. I will show all these transformations since this is a beginner problem. So those add off, which is what we wanted to have happen. And it's still equal to, let's see, 142 minus 2 is 140. So now I'm down to, I have one step left. So I'm going to go ahead and show this transformation. I'm going to divide both sides of this equation by 2 because I want these 2's to cancel out. So the last thing we see here is that n equals 70. So that's the first integer. So we're not done yet, right? So we're looking at our number line here, and we have that n equals 70. So the next integer, the second one, must be 71, and the third one must be 72. So the correct answer is the 3 numbers are 70, 71, and 72. All right, let's look at a second example. Example number 2, here we go. Find 4 consecutive integers. So now it's not 3, it's 4 consecutive integers, but we know they're consecutive, they're all in a row, such that 8 times the sum of the first and third is 40 greater than 10 times the fourth. So again, let's start off the same way we did last time. Let's craft ourselves a number line. And I'll spread these apart a little bit further. So 1, 2, 3, 4. So I'm going to let the first one equal n. The second one is going to be n plus 1. The third one is going to be n plus 2. And the last one is going to be n plus 4. So don't forget, this is the first, the second, the third, and the fourth. Because I'm going to show you in just a minute, less than a minute, one common mistake. So it says 8 times. We'll go back to white. 8 times. So I'm 8 times a sum. So I'm multiplying by sum, S-O-M-E, sum, S-U-M. And it's the first and the third. So the first is n, and the third is n plus 2. So this is the common mistake I was going to tell you. Sometimes when people read third, they think this number also has to be a 3. But the first one's n, second is n plus 1, third is n plus 2. So don't make the mistake of putting a 3 here. Now, it says that this is, that's an equal sign in math, right? 40 greater, so 40 greater than what? 40 greater than 10 times the fourth. So 10 times n plus 3. And look at what I did. I made the exact same mistake I warned against here, didn't I? That's okay, there's no such things as mistakes, right? Just happy little accidents. So n plus 3 goes here. That is my fourth. So let's go through and we'll just simplify this step by step. So I'm going to add up inside the parentheses here first. So that would give me a 2n plus 2. And that's equal to, I'm going to distribute here. That's going to be 10n plus 30 plus 40. All right. Let's see. Now I'm going to distribute here. So I'd have 16n plus 16. And combine some like terms over on the right-hand side. So that's 10n plus 70. And then I guess I will subtract. Subtract 10n on each side. Got to put all my variables on one side. And at the same time, if I'm putting my variables on the left-hand side, I could be getting rid of this constant by subtracting 16. So those both add off. So 6n is equal to 54. So divide both sides by 6, and 54 divided by 6 is n equals 9. So another common mistake. Students get very excited if they get the correct answer here, but they kind of stop. And they just say, oh, 9. So my correct answer is that the first integer is 9. So the second one must be 10, then 11, then 12. So the integers that we were looking for in this problem are 9, 10, 11, and 12. All right, let's look at a third example, and I'm going to change it up just a little bit. So example number 3, we're going to find 3 consecutive even integers such that the sum of the first and second equals the sum of the third and negative 10. So the fact that these are even integers, okay, don't let that alarm us. That is going to just mean they're going to be spaced out a little bit more. So suppose this number is even. I let the first integer be my first even integer. What will the next integer be? Well, if this one is even, this one must be odd. So the next integer, the second even integer, is going to be n plus 2, because this would be n plus 1, the next consecutive integer. All right, then we're going to skip again because we went even, odd. I'm just going to use E's and O's. And we'll skip to another even one. So this is the third even integer. So it's going to be n plus 4. Because I've gone forward now 1, 2, 3, 4. I have the right ones in here this time. So now let's set this up. It says the sum of the first and the second. So the first and the second equals the sum of the third and negative 10. So let's do that. We can do that. So the sum of the first and second, so it's a sum, and the first is n, and the second is n plus 2, and it says that it's equal to, so that was the sum of the first and second, and it equals, so here is my equal sign, and it equals the sum, so I'm going to put another sum in here. I can turn my drawing tool on. The sum of, let's see, the third, that's n plus 4, right? My third integer, even, odd, even, odd, even. So my third even integer is n plus 4. So that's the same as n plus 4 and negative 10. So the sum of the third, which is my n plus 4, and negative 10. So now I'm ready to go. So I'm looking at the right-hand side. I see two like terms. Two like terms. Over here, I see two like terms. 4 plus negative 10 is negative 6. Let's see. I kind of like to put my constants on the left-hand side, so I'm going to subtract n on each side. And if I subtract n on each side, that's going to put my n's on the left-hand side. So I want to put these constants on the right-hand side. So I get rid of these on the right. I should change color. Got rid of these on the right and these on the left. So equal to, n is equal to negative 6 and minus 2. So negative 6, take away another 2, is minus 8. So n is equal to negative 8. So double check, is that an even integer? The answer is yes, that is even. So the answer I'm looking for is the first integer must be negative 8. So this is negative 8. And then I go up 2 to negative 6. And then I go up 2 more, and that would be a negative 4. Common mistake. Sometimes at first blush, we go 8, 6, 4. Those numbers are going down, but they're actually going up on the negative side of the number line. So be very careful with this one. So that's why I saved this one for now. And I'm going to show you one more, a fourth example, but it's not going to be even. It's going to be odd integers, and the setup is going to be surprising. All right, so fourth and final example. Find 3 consecutive odd integers this time, such that the sum of the first and third is 7 greater than the second, decreased by 18. So we got some good vocab words going on in here. Being decreased, odd integers, sum, greater than. So we have a few things going on here. But here's the interesting thing about the setup here. I'm looking for 3 consecutive odd integers. So if my first integer is n and it's odd, what is this next integer? It's even. So n plus 1 is even. So I want the next odd integer. So that is going to be n plus 2. Then this guy is even again. So that's n plus 3. And finally, the third consecutive odd integer is n plus 4. So it goes odd, even, odd, even, odd. So even though we are using odd integers, I still have n plus 2 and n plus 4 in these problems. So let's go ahead and set that up. Let's see. the sum of the first and the third. Well, the sum of the first and third, let's go ahead and set that up. The first is here. This is the first. This is my second. Doesn't hurt to label these. And the third. So n and n plus 4. Okay, that's equal to. Is means equal to. 7 greater than. Well, no, I don't want to do that actually. This sum is 7 greater than the second. The second is n plus 2. The second decreased by 18. So this whole thing has got to have 7 added onto it, because the problem says the sum of the first and third is 7 greater than the second decreased by 18. So a lot of this is just going to add up anyway. I don't have a lot of things that I'm doing in terms of multiplying here. So let's go ahead and wrap this one up. So on the left-hand side, we have 2n plus 4. On the right-hand side, I can safely remove all of these parentheses because there's no negative signs out in front to worry about. You don't have to distribute them. So n plus 2 minus 18 plus 7. So again, remember, if this one is greater than this one, I have to add 7 to this one to make it equal. So 2n plus 4. And that's equal to n. Let's see, let's add up all of our integers here. I have 2 and 7, which is 9. So 9 and negative 18 is negative 9. Then, because I will go ahead and subtract n on each side, giving me n on the left-hand side. Gets rid of this on the right-hand side. And then I'm going to also do, let's do minus 4 here, minus 4 here. So on the right-hand side, well, the left-hand side has those go away. The right-hand side has negative 13, right? If you're at negative 9 on the number line and you go down 4 more, you're going to be at negative 13. I think one of us was thinking of that, but that's okay. So negative 13, that is my first number. So negative 13, the next odd integer would be negative 11. Again, remember, we're counting up in negatives, so it's not going to go this is not going to, for instance, go 13, 15, 17, because we're increasing. So negative 13, negative 11, and negative 9 is our final answer. So I should give you one more and see if you can put the answer for me down in the comments below. So for this one, enter your response in the comments below. Find 4 consecutive odd integers such that the sum of the first and the fourth is 25 greater than the opposite of the third. The opposite of the third. Be careful with that. You're going to be distributing a negative. I hope you like the integer word problems. Give it a thumbs up. Won't you please like and subscribe? I would appreciate that so much. So thank you very much. I knew you would. Until the next time, don't forget, math is not a spectator sport. Math is a participation sport. So if you want to get good at math, you need to do math.